beta for the variable for it. It's measured in decibels. I'm just putting it here in parentheses. The variable we use for intensity, the unit, the decibel is dB here. And this just compares the sound intensity to some reference level. The reference level intensity here is just I naught. And the regular sound intensity that we're going to measure, we'll just use an I for. But there's an equation here for the sound intensity level, or the decibel level. It's beta is equal to 10 times log of I over I naught. Where in general, we're going to use the same I naught we've been using before, the 10 to the minus 12 watts per square meter for the threshold of human ear. It doesn't have to be this value. This could change if your reference level, you want it to be something different. If you wanted to compare to the reference level of the threshold for a dog's ear instead of your ear, then you could. But for our ears, we're always going to measure to our lowest level. This is like the bottom. That's the lowest sound intensity that we could hear. That's why we're going to use this here. For all the problems we're going to do, we won't switch this. So this is beta in decibels. Did you all master logs when you took college algebra? That was your favorite chapter? It's usually, I get that reaction, it's usually one of the harder units for people in math, just because for a lot of you that was your first exposure to that, where you've been doing algebra with x's and y's for a while. Sometimes this was, for some of you, your first exposure to it when you took math. Do you all remember how to solve for something inside of a log? Okay.
Inverse log?
You raise it to whatever the base is. Good thing for you, though, is that we're not going to need to do that. Okay, so don't worry about that. This, for the purposes of what we're going to do, I'm going to ask you to solve for some intensity levels in decibels. You're going to solve basically by plugging into that equation. Now, you should be capable of solving for an intensity in here. What intensity would give you a decibel level of 50? That's something that I could ask you to solve for. I'm just not going to do it on this test, and you're not going to do it on the homework. Okay? Those of you who are taking physics 2, you will need to work with logs and be able to solve for things inside of here next semester, so you can start studying now. We'll see it in the last week of the semester when we start talking about radioactivity. But for now, don't let the logs scare you. You do need to know where to plug it in on your calculator, how to find that button. But these will be very simple. If you know the equation and you know when to use this value right here, this is really just another question that I'm considering 3 points if you know the equation, because it really is just a matter of, I want you just to find some decibel levels and plug it in, and just know that the intensity level in decibels is different than in intensity I. You've got to be able to use this and know what goes where, but you'll find that pretty easy. It really is just going to be a matter of plugging into an equation, or into that equation. So add that to your list of things to memorize. I'm just going to pull up a table that's in your book that has some different intensity levels, just to show you what some of the numbers look like. And then we'll calculate a few on our own here in a minute. And this is number 7, where it says convert a sound intensity from watts per square meter to decibels. Right, that is just converting, not just a conversion, plugging into the equation, but going from watts per square meter, intensity units here to decibels is just using this equation. You're going to be plugging in some value for I up here and solving for theta. Okay. I don't think those are on the homework in the Mastering Physics. There might be one just for practice in the other section. If you can do what we're going to do here now, or the problem that's on our sheet in a minute, then that's really all you're going to need. Okay? This table in your book, you don't need to know any of these numbers or have them memorized, but it's maybe useful just to know for reference the kinds of numbers that you might expect here. We're going from numbers kind of on that order of 10 to the minus 12 or something bigger in watts per square meter to decibels here that are all in this kind of order of something between 0 and 100. You'll see up here, I don't know if you can see clearly, but this table's in your book if you want to look at it. I didn't write the page number down, but it's table 14.2. So a decibel level of 30 is faint, quiet library, or whispering. It also kind of shows you on here the time of nonstop exposure that can cause damage to your ears. If you look, like right here, extremely loud, a stereo headset at full blast, or a rock concert for 30 minutes, that's 110 decibels. You're doing damage to your ears by that. Now, I know I see some of you walking around with your Beats by Dr. Dre, and if I can hear you from around the corner, I know music sounds better when it's loud. I'm not trying to sound like an old man here, but when you have these things on your head and I can hear it from around the corner, you're doing damage. Okay? I know you may not care, but you ever drive by an old neighborhood with a bunch of old people and you can hear their TVs when you're on the road? Yeah, I can hear my grandparents' TV from the corner when I come to go visit them. Now, part of that's just old age, but you can speed up the process if you want to by doing some of these things here. That's why you really need ear protection for any of these kinds of things. It does have a sporting event down here. You've been to the games here where they show that little meter up. They're showing you a decibel level. Everybody tries to get loud and cheer for the Thunder and then make the needle go up and do damage to your ears. But it's worth it, right? To watch your team lose. No, I watched my team lose 3 times in the playoffs last year. So I shouldn't be talking. So again, the numbers here though may be useful to kind of think about the scale, the size of numbers that you're on. I'm probably not going to give you an intensity that's going to give you something unrealistic. These are numbers that we should expect to see here for decibel levels. So if you're getting things like 2,000 for your beta, your decibel level, up here is painful, very loud sounds, doing damage right away. That's not the top end of our scale here, but you're not going to have thousands and thousands of decibels. We're on this scale here when we're talking about here the threshold of the human ear being down at 10 to the minus 12. Okay? So if you look at the second problem on your worksheet, let's just calculate the intensity level for those 2 different sound intensities that I've given you there on that sheet. So pull out your calculators, make sure you can find your log buttons and plug those in. But I just need you to be able to use that equation to describe an intensity level in decibels. Mistakes on your calculator on a problem like this are sometimes half credit mistakes because there isn't much partial credit here. Part of the credit is writing the equation down, and the other half credit sometimes is plugging the numbers in correctly. So just make sure you plug those numbers correctly. Do it here with the calculators to make sure you get the correct answers, and that's really all that's to it here for this beta equation. So I'll give you a second to plug those in and find the 2 intensities there for that number 2 on our